As of July 31st, there are a total of 17.3 million cases and 650,000 deaths globally due to the novel COVID-19 pandemic. Approximately 4.5 million cases originating from the US alone have virtually affected every aspect of society. I know your feelings about the present situation, and you might be surely wondering what reasons have contributed to the spread and what impacts it has on our society. In this summer project, our team focused on understanding the spread of the virus and its impact on health, transportation, weather, unemployment, and economy using data science. The mathematical data-driven models that were created all made use of an artificial neural network. An artificial neural network is a form of artificial intelligence that is based on the way a human brain learns and makes decisions. In order to improve the performance of the neural network, the network is trained using many examples known as training data. These training data were collected from publicly available data and then used to develop the network to make more accurate decisions and generate analysis.
For the health lens of COVID-19, a neural network was created to analyze which factors have the biggest impact on its spread and the health of those that it affects. The model takes in a variety of inputs such as U.S. Census statistics and statewide policy data for COVID-19. The model then predicts the number of cases for a given month in every United States county and finds which inputs to the model are most influential in the model's predictions. The graph displayed on screen shows the predicted number of cases versus the actual number of cases for COVID-19 on July 21, 2020.
A model was generated to evaluate the environmental effect of the pandemic in 4 different regions of the U.S. by utilizing weather data such as temperature, dew point, and air quality alongside data related to the spread of the virus. From the heat map shown, it was found that the environmental factor which exerted the greatest influence on virus transmission was the wind speed, depicted by the pink blocks. A negative correlation denoted that higher temperatures were associated with lower infection rates, depicted by the dark blue blocks. This finding validates the hypothesis that greater ambient temperatures can slow the spread of the virus, as respiratory droplets transmitted by individuals are prone to evaporation and spend less time in circulation.
To analyze the after effects of COVID-19 on the US economy, a neural network that predicts the World Uncertainty Index was created. This index quantifies macroeconomic uncertainty due to events such as pandemics. The graph shows that the model captures the overall trend with a 10% error, but needs optimization for performance enhancement. Preliminary analysis shows that GDP growth rate, and consumer price index contribute the most uncertainty. A heat map showed a similar correlation. The model predicted with a 0.78 probability that the third quarter 2020 will be a recession.
Taking a deeper look into one of the United States' early hotspots, New York City, there has been a wide availability of transportation data due to being an urbanized and developed area. Thanks to Google's large database, we can make key observations. We can start by observing one of the 5 counties as a case study, Bronx. During the initial hit, traffic at a nearby airport has been reduced by almost half. Notice that the 7-day average of new positive cases starts to sustain during the middle period, then applies a second wave. However, looking onward to recreational and retail travel destinations, both non-essential travel, there is an obvious correlation between travel and new positive cases. This can be used to push certain government policies for prevention.
The global supply chain has been severely affected by the shutdown of factories, ports, and travel restrictions being imposed. This has negatively impacted many US industries. On top of this, lockdown measures has reduced economic activity, which has caused a huge spike in the unemployment rate. Using employment statistics from different industries, a model has been created that can predict the unemployment rate and determine which industries are the most severely impacted.
Using this approach, the team was able to find key patterns related to the important topics in COVID-19 data such as weather trends, unemployment rate, and factors in the spread of the virus. Our data science models can serve as a basis for government policies or human decisions to control the current and future pandemic. Prior to the summer research program, many of us had very little experience in data science and in the formal research process. Our advisor had a systematic approach in developing the necessary core skills and research framework for success. This was done so through a very open communication and dedicated skills training. Because of this passionate advising style, our ability to work as a collective team flourished, and our capability to conduct formal research improved. As a result, many of us are now better suited to perform research, and would like to continue with this research if possible or apply our skills in another field. We sincerely acknowledge the great support from sponsors, the School of Mechanical Engineering, and Purdue University for providing this great opportunity. This program enabled us very effectively to tackle a real-world problem collaboratively and remotely. This project has not only given us a valuable summer experience, but encouraged us to pursue future research opportunities to contribute to society. Thank you for watching, and we hope everyone stays safe.